Hi everyone, welcome to the next video in the series. The title of this video is Intro to U Substitution, and we've been looking at finding the integral or the antiderivative of derivatives and coming back to a function. And this is a technique that we would use if we used the chain rule. So stay tuned, here we go. So to begin, let's look at functions that require the chain rule to derive. So our first function that I have listed here is y equals sine 2x. And remember that any trig function, to take the derivative, you would use the chain rule. So I'm going to write dy dx, I'm going to use that derivative notation, is equal to the derivative of the outside, which is cosine 2x, times the derivative of the inside, which is times 2. Now, to take the antiderivative, right, I want to take the antiderivative of dy dx, or of y with respect to x. So I'm going to write it this way. Dy equals, I'm going to leave it separate, cosine 2x times 2, and then I'm going to multiply the dx to the other side, so that I have everything is x on the right, everything is y on the other. And then when I integrate this, the integral of dy is just y. And then the integral of this, if you'll notice here, this is the derivative of the inside. But the antiderivative of a derivative should get us back to the function. So if I integrate cosine, I'm going to get sine 2x plus c. Now, if you'll notice, the y equals sine 2x, is what we had to begin with, and when we take the antiderivative, we get the same thing. So something curious is going on with this piece right here. This could be, one thing I could do here is I could make the 2x a u, and then this here would be the derivative of u. Okay, so the plot thickens. So our next example is going to be y equals the quantity 2x plus 1 to the third power. All right, so once again, chain rule. So when I take the derivative of y with respect to x, I take the derivative of the outside times the derivative of the inside. And once again, to take the antiderivative, we're going to get back to the function, right? I would have dy equals, and notice that I'm writing it separately. I'm not going ahead and multiplying, making that a 6, because I want us to begin to look and see if we can see a pattern here. dx. Now notice again, that's the derivative. The part I have underlined is the derivative of the inside. That's the derivative of the inside. All right, so when I integrate both sides, I have y equals 3, this part to the third, over 3 plus c. And then this part on the inside is 2x plus 1. So you can see here again, this part on the inside, this part right here, could all be u, and then this part right here is the du. Once again, this is the derivative of u, the inside. So u, and then this is u. Okay, last example, y equals, y, looks like a G, hold on, y equals the square root of 3x plus 1, which, as we know, is really 3x plus 1 to the 1/2 power. Once again, chain rule. So I have dy dx is equal to 1/2 times the inside to the negative 1/2. We write the inside just the same, times the derivative of the inside. Okay, and if we want to take the antiderivative, dy equals 1/2, negative 1/2 times 3 dx, 3x plus 1. Notice that's the derivative of the inside again. If I integrate both sides, I get y equals 1/2 this to the 1/2 power divided by 1/2, which is times 2, plus c. And so if I do this again, I get 3x plus 1 to the 1/2. So the antiderivative of the derivative gets us back to the function. That's the fundamental theorem of calculus. So the previous examples showed us how we went from a function using the chain rule to a derivative, using U substitution as an antiderivative to get us back to a function. And so what we're going to actually do is we're going to have problems that are integration problems. And we're going to know when they're of a certain form that they have these problems. For instance, this one right here is the result of using a chain rule. And so it may have to be rearranged so that it looks more like something that would have occurred with a chain rule so that we can do an antiderivative on it. Now, this idea of substituting makes it look a little bit more like a chain rule. And so that's the technique that we're going to learn. So I'm going to do this example, and then there are going to be several more examples throughout the video that outline the process in detail. So let's rearrange this. I'm going to change to purple, right? I'm going to move this x over next to the dx. So I have an integral of something to the 5th power and then the x dx, right? And so this is going to be my du. But first of all, I have to know what u is. So the u is going to be this part on the inside, this x squared minus 1, right? So the du is going to be 2x dx. Well, I'm looking here. Do I have 2x dx? No, I just have x dx. So this is not complete. So it needs the additional 2 added to it, or multiplied, right? But if I multiply the whole thing by 2, then now it is not the same value or the same form. So I need to also multiply, and we'll just multiply it over here to get it out of the way, but we'll multiply it times 1/2. Because remember, 1/2 times 2 over 1 is just a form of 1, which is what we need. Okay? So this piece in here, this x squared minus 1, the x squared minus 1, remember, is u. And this 2x dx is du. So we could actually substitute here. We could say 1/2 u to the 5th du. Well, now this just looks like a regular integration problem, right? We have 1/2 u to the 6th over 6 plus c, right? So this would be 1/12 u to the 6th plus c. Well, what is u? U is x squared minus 1. And so this is the antiderivative of this value. That's what the original function was. So here's example number 2. We have the square root of 5x minus 2. My u is going to be what's under the square root symbol, so that's going to be 5x minus 2. Du dx is going to be 5. Solve for du, so du is going to equal 5 dx. All right, so I'm going to rewrite everything, and I'm going to go ahead and do 5x minus 2 to the 1/2, and then dx. All right, so I go back here, and I notice that I need a 5. That would make that du. I can't just add a 5, so I'll have to add a 1/5. I'm going to rewrite this in terms of u, so I have 1/5 u to the 1/2 du. Okay, I'm going to integrate, so that's going to be u to the 3/2 times 2/3 times 1/5. So that's going to be 2 2/15 u to the 3/2. All right, then I'm going to change it back, so I've got 2/15. My u was 5x minus 2 to the 3/2 plus c. So here's another example. We know that this problem, this right here, was the result of a derivative. This is a derivative. And we are integrating the derivative to get back to a function. So we also know that this was a chain rule, but it's an incomplete chain rule because the derivative of the inside is not with the dx. So let's start a different technique. This time we know that u is 5x plus 2, right? And we know that du is 5 dx. Well, we're close here, right? We need to add a what? A 5. And if we add 5 here, we have to add a form of 1, so we're going to add 1/5 out here. Well, let's rewrite. 1/5 integral of u to the 1/2 du. Right? du is 5 dx. I'm good. This is du. U is this, right? That's u. So it's the square root of u. All right, so we're going to do u, add 1 to the 3/2 times 2/3 times 1/5 plus c. So I have 2/15 u to the 3/2 plus c. And what is u? Well, u is 5x plus 2. So in the rest of the video, I work several more examples using this technique. What I would like for you to do is write the problem down in your notebook, stop the video, work the problem, then fast forward so that you can see what the answer is. If you get the correct answer, move on to the next example. If you miss something, go back and watch the entire explanation for that problem. But in your notebook, I expect you to have all examples as part of your notes. So that being said, let's continue in the video with the next example. So here's example number 3. We have the integral of x squared, square root of 1 minus 4x to the 3rd dx. Once again, we start with u, and u will be what's underneath the radical, so that's going to be 1 minus 4x to the 3rd. I'm going to find the derivative, which will be negative 12x squared, and then solve for du, so du equals negative 12x squared dx. Okay, so now I'm going to rearrange the original. So I have 1 minus 4x to the 3rd to the 1/2, and then here's my x squared dx. So at this point, we go back and we look at the du. du is equal to negative 12x squared dx, right? So if we want to change this to u to the 1/2, then this has to be equal to this. So notice that we're going to add again that negative 12 so that this now becomes that entire thing, and then multiply times 1 over, negative 1 over 12 on the outside so that that's a form of 1. One important note here, we can add numbers all we want. We cannot add variables. So if the x squared were not present here with the dx, we could not integrate this. We can't add x's. All we can add are numbers. Okay, so let's rewrite this in terms of u. We have negative 1/12 u to the 1/2 du. Integrate, so here's my negative 1/12 u to the 3/2 times 2/3. So that will be negative 1 over 18 u to the 3/2. And then we just rewrite it. So negative 1 over 18 u, which is 1 minus 4x to the 3rd, to the 3/2 plus c. So here's another example. We have this cube root in the denominator. So since that's the cube root, that's my u. So I've got 2x squared minus 1. And then when you take the derivative of that, you get 4x and solving for du would be 4x dx. Change the original, so I'm going to go ahead and write the denominator, 2x squared minus 1 to the negative 1/3 and then I have x dx. All right, so when I look at the du, I notice that I need the 4 and the 1/4. So then I'm going to rewrite. So I've got negative 1/3. I have the du, so I can write du instead. That should be an integral sign. Then I'm going to integrate. So u to the 2/3 over 3/2 times 1/4. So that's going to be 3 over 8 u to the 2/3. So I have 3/8 u, which is 2x squared minus 1 to the 2/3 plus c. Okay, here's our fifth example, and I don't know, I tried to add the 9 there, but that is to the 9th power. So whatever it is to the 9th power, that's going to be my u, so that's going to be x to the 3/2 plus 2. Du dx is going to be 3/2 x to the 1/2. And so then du would just be du is 3/2 x to the 1/2 dx. Now I'm going to rewrite. So this is my x to the 3/2 plus 2 to the 9th power, and then I have x to the 1/2 dx. And I'm looking here, and I see I have that part, but I don't have the 3/2, so I'm going to add that. To make that a form of 1, I'm going to multiply by 2/3. I'm going to rewrite this in terms of u. So this will be u to the 9th du. This is u to the 10th over 10 times 2/3. So this will be 1 over 15 u to the 10th. 1/15 u is x to the 3/2 plus 2 to the 10th plus c. This will be our sixth and our final. Each one of these has a little bit of a twist to it, so I hope you took notes. Even better, I hope that you will write these down and work the problems ahead of me, and then watch to see how I did it, or skip to the end and see what the answer was and see if you did it correctly. That's probably the best way to learn how to do this. So once again, we're looking for u. This one is a little more complicated this time because it's still got the radical, and that's going to be our u. So we have x squared plus 4x minus 3. And then I'm going to take the derivative, which is going to be 2x plus 4. Solve for du, so du is equal to 2x plus 4 dx. Rewrite it. So I have x squared plus 4x minus 3 to the 1/2 power, and then x plus 2 dx. Well, as you can see, we're close, right? If I just multiply that all the way through if I multiply this by 2, then I'm going to have 2x plus 4. So I'm going to multiply this by 2, and this times 1/2. I'm going to rewrite it in terms of u. This whole thing right here is du, substitution. This is u. So I have all of that written. I'm going to have u to the 3/2 over 2/3 times 1/2. So that's going to be 1/3 u to the 3/2. So when I get ready to write this, I have 1/3. U is x squared plus 4x minus 3 to the 3/2 plus c. And that will be our final. So when we come to class, we're going to practice finding u. Sounds kind of funny. Finding u, taking the derivative of u. We're going to practice all these bits until you'll be able to do some pretty complicated u substitution. So I will see you in class.